Hi class, and welcome to your first lecture video for college algebra. Today we're going to cover section 1.1. One thing I will say before you get started is don't feel afraid to kind of take some breaks as you hit parts where you're just realizing you're not really paying attention too much anymore. Something like that, take a little 5-minute break, get some caffeine or whatever you need, and come back to it, okay? That's the awesome thing about these videos is you can rewatch things that maybe didn't make sense the first time and take breaks when you need to make sure you're retaining all the information possible. I'll try to remember or kind of point out places that would be good to stop as I'm going through as well. But just remember that at any point in time, make sure you do that. Just always make sure you come back and finish the video because everything will be important for learning the lesson, preparing to do your homework, and things like that. All right, so let's get started. Section 1.1 is all about describing single variable data. So we're going to be looking at all types of data, single variable, and in the next section, 2 variable data, here starting out in chapter 1. So let's talk about first, just a quick review of what a variable is and what data is exactly. So a variable is just a quantity or category that changes. So it's that thing that we're interested in that's changing, and typically we're trying to find out why it's changing or what's causing it to change. So, and here sometimes you'll see as I'm talking, I'll start writing the same word again. But here we go, we've got a quantity or category that changes. That's what a variable is. So it's the thing we're interested in looking at. And in order to figure out things about how this variable is changing, maybe eventually figuring out what's causing this variable to change, what we're going to do is collect data about that variable. So that data is just the information we're collecting about the variable. So let's get that down there so we can remember what data is. So information collected about the variable. The very first thing that happens with collecting this data about variables is that there's really 2 types of variables we want to focus in on, 2 different categories of variables rather, because once we can place variables into one of these categories, we tend to handle them differently. The first category is a quantitative variable. A quantitative variable is one that can be represented by a number. It's a quantity. And that number we always want to make sure comes with a unit of measure. Always important we have those 2 things together. So it's a quantity, it's something we can measure, it's a unit of measure with a number. So to get kind of a better handle on that, a couple examples of quantitative variables are height and weight. Height can be represented as a quantity. A data point you could collect with height would be something like 6 feet, a number with a unit of measure. A data point you could collect with weight, something like 160 pounds. Again, very important here that that unit comes with that number, otherwise the number really means nothing to us. We have to have that unit along with the number. Now, some variables, things that can change, aren't measurable. They're just categories. So we put them into a separate category themselves, the qualitative variable, also known as the categorical variable. Because I don't know about you, but I get a little tongue-tied between quantitative and qualitative. You'll probably hear me get tongue-tied between it in this video. So I often like to refer to the qualitative variable as a categorical variable. And again, it's just that variable that's represented by the category rather than by the quantity. So an example of this would be like if we surveyed a bunch of students in a class about what their majors were. When you report your major, this isn't a measurable quantity, it's just a category you fit into. Okay, so an example here would be something like math or science or art. Okay, those are all different categories that you could fall into for whatever major you've picked. It's not something that's measurable. It's not something we can put a number and a unit to. All right, so the one we're going to focus on most for the rest of this section is the quantitative variable, mostly because, right, in math we like numbers, We can do calculations with numbers. So we're going to look at some of those calculations we can do in order to look at all these different variables, what kinds of things we're interested in when looking at the data. And we will then jump back to qualitative variables and what we can do with those at the end as well. The key here being eventually visualizing both types of variables. Before we get there though, we're going to start off with that quantitative variable. And the very first thing I want to talk about is how to convert units of measure. We just talked about how important it was for these quantitative variables to come with a unit. It's also incredibly important that when we collect data, we get all of those data points to be in the same unit. And sometimes that won't happen, right? We know that other countries, for instance, mostly work in the metric system, while we work in the US customary system of units. So if we were to take some data points from overseas and take some data points from our own country, they more than likely wouldn't have the same units, and we would need to make sure to get them in terms of the same units before putting all of those data points together. So I just want to talk about how that happens. How do we get data points? How do we convert them all to be in terms of the same unit? So the way we're going to do that is with what's called conversion factors. So right now it's just a word. We need to figure out what a conversion factor actually is. So a conversion factor is actually a fraction that is equal to 1. And it's equal to 1 because it's going to express a measurement in 2 different units. So we're going to have 2 different units, but they're going to be equivalent. And when we have this fraction set up, it can then be used to convert a measurement from one unit to another. So I'm just going to give you first an example of a conversion factor. So a typical conversion we know here in the States is that there's 12 inches in a foot. Those 2 things are equal. So if I set up that fraction, I can either think about it as 12 inches in a foot, or the fact that in 1 foot there's 12 inches. Either way, that fraction is equal to 1 because those 2 quantities are the same. And whenever I take something divided by itself, it's equal to 1. So that's a conversion factor. But now the key is, okay, great, I have this conversion factor, it's equal to 1. How is that going to help me convert from inches to feet or feet to inches? That's what we're going to look at next. How do we use these conversion factors? And how do I get some more conversion factors? It was great that I knew there was 12 inches in a foot, but what if I need to do something like this first example here, where I want to convert inches into centimeters? I don't know about you, but that's not something I know off the top of my head, how many inches there are in a centimeter or vice versa. So what we're going to have in this class and what you've seen posted in Talon is there's a unit conversion sheet that I have provided for you for this section. So that's all you're going to use. So don't use Google for this particular conversion, okay? Google will do conversions for you, but I want to see that you can set up those conversion factors and use just the ones I've given to you in order to do these next conversions, okay? So I'm going to pull up that unit conversion sheet. This is what you have available to you. Sorry, I've got some stuff written on there from working with it before, so let me get rid of that stuff. We're going to work with it now, okay? But this is your unit conversion sheet. It's got all different types of conversions on it. You've got some different categories here, like length, volume, mass and weight, and time, okay? We're going to actually use this later on in the class. You don't have to worry about that right now. You're mostly looking at the rest of the unit conversion sheet for this particular section. So what this is going to help you with is getting to those conversions. And that one we were just looking at, we wanted to go from inches to centimeters. So that's going to be under length, because inches and centimeters measure length. And I'm going from the US customary system to the metric system in length. I'm going from inches to centimeters. So right there, I have the conversion factor I need. If I take 1 inch and divide it by 2.54 centimeters, or the other way around, I'll have a fraction equal to 1 because those 2 things are equivalent. So let's use that and set up and see how we use a conversion factor to solve that problem. So back to the problem. We've got that 16 inches need to be converted to centimeters. So here are the steps I like to follow. I always start by writing down what I have. I have 16 inches. Now, you're always going to multiply by that conversion factor because if you multiply anything by 1, it stays the same. So we're going to multiply by the conversion factor, and now I need to make sure it is set up correctly. Remember how we could put 1 unit on top or on the bottom? So we need to decide, does inches go in the top of this conversion factor or in the bottom? And what you start with will always go in the denominator so that the units can cancel. Units will cancel just like numbers can cancel. So I want to go from inches to centimeters. So since I want to end with centimeters, that will be in the numerator. Now I can fill in my numbers. Remember, I knew that in my conversion, there was 1 inch, so that needs to go with the inches, and 2.54 centimeters. So the 2.54 must go in the numerator with the centimeters that I set up there. And now what happens is I'm multiplying two numbers, so I can think of any whole number over 1. And to multiply fractions, I just multiply across the top and multiply across the bottom. So here, the units will cancel, and in my numerator, I end up with 16 times 2.54 centimeters. And in my denominator, I just have 1 times 1. So my final answer will just be found by taking 16 times 2.54. That gives me 40.64 centimeters. And I'm done. Okay. Sometimes these decimals will not be nice and round, and I will always tell you what to round to. Like here we rounded to the nearest hundredth or to the nearest 2 decimal places. Okay, so let's just continue with that for the rest. If we have any question about where to round to on the next ones, we're just going to round to the nearest hundredth when necessary. All right, this next one is very similar. So I would pause the video right now, see if you can get the right answer here, see if you caught on, and then come back and see if you got it right. Okay, so on this one, we're going from yards to meters. So I need to go back to my conversion sheet, and I'm again in terms of length here, because I'm going from yards to meters. And here again, I'm going from a US customary unit to a metric unit. So I'm going to use this conversion right here. One thing I do want to point out here. Notice on this conversion that we have a little squiggly equals to sign. You see that there? That means this is an approximation. A lot of the time when we go from the US customary system to the metric system, we don't get nice even numbers like we just happened to with the inch to centimeter. It's not something that rounds perfectly well. So that means that if you happen to instead have looked down at this category and seen your conversion from yards to meters, let's see, in this case, it would be yards to meters right here. If you use this conversion instead, your final answer will be rounded differently. You should get close, but it will be a different final answer because those conversion factors are rounded. Now, you could have used either one of these, but I would go with and try and always go with in your list, because we were going from US customary to metric, we want to use this category. Okay, now if you happen to accidentally use this one, that's all right, and your homework will still accept that answer, but just don't freak out if those answers are slightly different, because we're using rounded numbers, and when we use rounded numbers throughout calculations, we'll see some error in the end. Okay, so I just wanted to make sure to point that out, but we're going to use this one here in the example I'm about to do. So 1 yard is about 0.914 meters. So if you use that one, we should have set it up over here then as writing down the original amount. Make sure your conversion factor has yards on the bottom and meters in the numerator. And here it was 0.914 meters for 1 yard. So again, yards will cancel. Perfect, I've set it up correctly. And now I just need to take 110 times 0.914 and round it to the nearest hundredth. That is 100.54 meters. And I've got it. Okay. All right, this next one here is liters to gallons. So I've got liters to gallons here, so I'm gonna have to go to a different section of my unit conversion sheet because liters and gallons are talking about volume. So let's see if we can get from liters to gallons. So I'm gonna go back to my unit conversion sheet, but this time I'm gonna go up to that volume section, which is in the top right corner. And here I'm going from, I need something with liters and something with gallons. So I'm going from US customary to metric back and forth. Now this one doesn't have a second category, so I'm gonna have to be here, even though technically I'm going from liters to gallons. So I'm actually going from US customary into metric, okay? Or sorry, metric into US customary. But that's all right, we've got the conversion sitting right here, so this is the only one here that'll work. So that's what we're gonna do. And actually here, you know what? I'm seeing down here, we've got a liter to gallons as well. So you could use that one too, all right? Either way, but I'm actually going to say, hey, I saw this one up top first, so let's go ahead and use that one because something different's gonna happen when I use this conversion factor over this one, and I wanna show you how that setup looks a little bit different, okay? So again, if you happen to use this one on the bottom, your answer should be very close, but will probably be a little bit different because again, we have another approximated conversion factor. All right, so I'm gonna use that top one because it's the first one I happen to see. So let's go back to the notes. Here we've got 6 liters, and I want to go from liters into gallons, and I was using the fact that there were 3.785 liters in 1 gallon. Okay. Now what happened here is that my number ended up in my denominator rather than in my numerator. That's totally fine. Just remember again how we multiply fractions. The liters will still cancel, but this time I end up with 6 times 1 gallons in my numerator and 1 times 3.785 in my denominator. So what that means I need to do is take 6 and divide by that 3.785 rather than multiply by that number. And that's why it's so important to set this conversion factor up correctly. It will always answer that question of, do I multiply by that number in the conversion or do I divide by it? So if you take that division and round to the nearest hundredth, you should get about 1.59 gallons. And we're done. Okay. Now this very last one is a good example of when you don't have a direct conversion factor on hand. So here I'm starting with 48 hours and I want to get to seconds. But the problem is if I go to my conversion sheet and I go down this time to look at time, I cannot get directly from hours into seconds. I have to go from hours to minutes and then minutes into seconds. So I'm going to have to use 2 conversion factors to get from hours to seconds. And that's okay. So notice the first thing I can do is get from hours to minutes. So here's your setup. The first thing you can do is set up a factor that gets you from hours into minutes. You still want to get rid of hours so it will go on the bottom. And you still want to fill in those numbers. There's 60 minutes and 1 hour. But you don't want to stop here because your final answer would be in minutes. You want to set up the next conversion factor. The next thing you want to do is get rid of minutes and go to seconds, which we could do because the next conversion factor we saw said that there was 60 seconds in 1 minute. Once I multiply by that, minutes will cancel and I'll have my final answer. Now, when I multiply through, I have 48 times 60 times 60 seconds over 1 times 1 times 1. So I need to take 48 times 60 times 60, and when I do that, I should get 172,800 seconds. And this you could do for a long time. It's kind of like putting puzzle pieces together. You might need 3 conversion factors or 4 conversion factors to get to your final answer. You might need to use a few different steps along the way, but that's all right. And what's very useful is to use setups like this so you can keep track of the information as you go. Otherwise, it gets very confusing very fast. All right, so that's how we're going to convert units and make sure that the first step is that if we have quantitative data, that all of our data has the same unit. If we have all the same unit, that's when we can start doing some calculations to understand the data and get some numbers that represent that data. The two numbers we're going to calculate in this section for quantitative data are two measures of center, mean and median. So these two measures of center are something that hopefully you've seen before. The mean is also called the average, so you might recognize that word more than mean. But the average or the mean is just the sum of all the numbers in the data set, and then you divide by the total number of numbers in the data set. Okay, that's your typical measure of center. Now, another measure of center that you maybe don't remember as well or haven't seen as often is median. The calculation for median is a little bit easier because it's just the direct middle value of the data set. So the most important thing with median is that if you're finding that middle value, that all of your numbers are in order from smallest to largest or largest to smallest, as long as they're in order. Then you can find that middle number. The only tricky part that happens is if you have an even set of data points, because then you're going to have two numbers in the middle. We're going to look at an example if that doesn't make sense quite yet. But if you have like 6 numbers in your data set, you're going to have 2 numbers in the middle. And what you're going to do then to find the median is just take the mean of those 2 numbers in the middle. So we'll essentially combine those 2 measures of center. Okay, we're going to do examples. So if you don't remember how to calculate these, we're about to do a couple examples of how to find them. All right, and then we're going to actually compare them, right? Because here it's a little confusing as to why we have 2 different ways of measuring the same thing, right? Both of these are supposed to be measuring the center. So why do we need 2 different measures of center? Shouldn't they be the same? Or will they not be the same? We're going to find out. So our first example here looks at the prices of houses in a neighborhood in thousands. So when you see 120, that house cost $120,000. And we want to find both the mean and the median, and then think about, okay, which one of those is actually going to better represent the set of data as far as a measure of center. So let's review how to find the mean. The mean, we sum up all the data points, so 120 plus 150, 135, and so on. Make sure you add all of these numbers together. That's almost the hardest part of finding the mean, is to make sure that you add all the numbers together correctly. And then you're going to divide by how many numbers there are. There are 7 total numbers here. Okay, so take and add those all up and divide by 7, and go ahead and for now just round to the nearest whole number, and we'll get to the nearest 1,000 there. So if you round it to the nearest whole number here, you should get 192, which means the mean price of a home is $192,000, okay? Because we're talking about homes in terms of thousands. All right, now let's see how the median compares, how another measure of center compares. Now, don't just go find the middle of the numbers in the list up here, because you'll notice these numbers are not in order. So I'm going to first list them in order. I'm going to go ahead and go from smallest to largest. So if you do that, you've got 120, then 135, then 150, 155, 160, 175, and 450, if you list them in order from smallest to largest. There are 7 data points. That's an odd number, so we're going to end up with a number in the middle. And I like to just visually do this. So I'm going to cross off an equal amounts from the top and the bottom. And there I've got my median at 155,000. Now, if you think about the price of a home, I'm going to care a lot about whether or not I'm spending $192,000 on a house or $155,000 on a house. typically, right, when you go home searching, you're gonna have a budget. You might even completely skip this neighborhood if you saw this number, whereas this number might put the houses in that neighborhood in your budget. So what's going on here? Why are these two things that are supposed to be measuring the center fairly different? So go back and look up at the data up here. What do you see? What could possibly be making these numbers so different? Did you see this really high value compared to all the other values here? So we have this home that's a lot more expensive than all the other homes in that neighborhood. And that's what's making this mean so much higher than that middle value of the homes. So what we're seeing here is that if we have some outliers in our data set, this mean gets affected, and we'll really actually want to look at the median instead to better represent the middle number of those values of homes. Okay, let's see if something like that happens again with this next set of data. In this next set, we're going to look at some grades that were received on homework assignments by students in a math class. That shouldn't be capitalized, but that's all right. And we want to find the mean and the median again. So this would be a good time to pause and see if you can find those means and medians correctly. So for mean, did you take, actually I want to switch that, okay. So for mean, did you take and add them all together? 89 plus 91 plus 91 plus 23 plus 87 plus 95? And did you divide by 6 because there were 6 total data points? That should give you a mean of about 79.3%. So the average score on the homework for that student would be 79.3. When you found the median, did you remember to line up the numbers in order? I'm going to again go from lowest to highest. So if you did that, it should be 23, whoops, 87, 89, 91, 91, and then 95. Okay, this time when you found the middle, you should have had 2 numbers in the middle, and that's where you need to make sure to find then the mean of those 2 numbers. So there you would have taken 89 plus 91 divided by 2 to get a median value of 90%. And now again, what are we seeing? We're seeing that those 2 numbers are not very close. What is happening here? This time we have a really low outlier. So that mean got pulled a lot lower than the median. So this is also a good example to bring to your teachers and say, hey, can you drop my lowest homework assignment so that my scores, so that my average is closer to my real middle of my homework scores, okay? So if you have one really low one or one really high one, sometimes that mean can be very affected. Now, that's also the reason why we typically like to assign a lot of homework assignments so that those scores don't affect them as much. But like in this class, your lowest 3 homework assignments will be dropped. And the idea behind that is because if they're outliers, that'll put that mean back up to closer to the real center of the data. A number that would represent all of your scores a little bit better. Okay, so one key thing here though is that both of these examples had outliers. Without outliers, the mean is still a better measure of center because it takes into account all the variability between the numbers, whereas the median does not. But if there are those strong outliers and there's a big discrepancy between the mean and the median, then we're going to look at the median as a better measure of center. Okay, so the mean is still the best measure of center unless there are strong outliers. And then we want to look at the median. All right. So just a couple of different statistics to describe those quantitative variables, those ones that can be measured by numbers. Now, just the center doesn't describe the data very well. We can also look at histograms, visualizations of the data in order to really see what's going on with all of the data points. So again, histograms is the visualization we're going to use for quantitative data. Okay. A histogram, you'll see an example down here. Two key things about a histogram are that this horizontal axis here is always a number line. It's a subset of the real numbers, so whichever numbers are part of our data set. And we want to make sure always that when we're working with a number line, the intervals are equally spaced. Otherwise, we're not really looking at a number line at all. And then this vertical axis here is always going to be labeled with what we call frequency or relative frequency. And I am going to review here really quick what those two words mean. Okay, so frequency just means the number of observations in that category. So how many in that particular category. So if we were looking at this histogram down here, we're looking at heights of trees. Those heights are in feet, and this vertical axis is frequency. So one thing we're looking at here, and one thing I want to make sure I note, is that on histograms, a lot of the time, this horizontal axis will be labeled differently. So as you see this 20, 40, 60, 80, and 100 here, it does not mean that there are a couple of trees here that are a height of 20. It means that there's a couple of trees that are a height between 0 and 20. And then there's about 4 trees here that are between 20 and 40 feet. And then there's about 1 tree that's between 40 and 60 feet tall. Okay, they're intervals. They're not labels that say there's this many trees that are 20 feet tall. Okay, you can always tell a histogram from just a category of 20 because all these bars are connected, so there's intervals here. Okay, so in this case, what we're seeing is frequency. It's telling us how many trees fit into that interval, how many trees fit into the next interval, and so on. All right, so as we continue here, we also want to talk about what else this vertical axis can represent, and we said it could also represent relative frequency. That's just another fancy word for percent. So relative frequency is the frequency divided by the total number of observations. Okay, so again, percent is maybe the more common word for relative frequency. And you just take however many observations there are in the category you're interested in. See if I can spell that right. And divide that by however many total observations there were, however many total data points there were. We're going to do an example of that here in a second. But that would be the difference. So instead of saying that there are 2 trees between 0 and 20 feet tall, you would see whatever percentage of trees in the data set that represents. Okay? Now, before we continue, it is a little hard to tell what these bar heights are. So we're just going to agree upon some heights here. I think that this first one looks to be about 2, so I'm going to label that. The second one looks a little bit lower than 5, so we're going to say 4. This next one's around 1. If you take a line back over this way, this one looks to be about 12, and this bottom one here is a little bit lower than the 4, so we're going to say that that's 3. Okay, that's going to be important just as we answer these questions that we all agree on about how high these bars are. Okay, so let's look at these questions. Can you understand this histogram enough to tell me how many trees are less than or equal to 20 feet tall? Less than or equal to 20 feet tall. So remember the 20 is on this line here essentially. So there's all the bars this way are the ones we want to look at. That's just one bar. So there's 2 trees that are less than or equal to 20 feet tall. The next question asks how many trees are more than 60 feet tall. Remember 60 is kind of like right here. The boundary point at that point. So we want to look at how many bars are above 60 feet tall. In this case, that's 2 different bars, so we need to take 12 plus 3. There are 15 trees that are more than 60 feet tall. All right, hopefully that's starting to make sense here as to what's going on with this histogram. It's a number line. We've got values of heights of trees that aren't all going to be the same, right? Trees are all different heights. It's very variable. So instead of saying how many trees are exactly this height tall, we're going to put it into an interval and say, okay, I just want to know how many are between 0 and 20. We could have also changed those intervals up. We could have made the intervals bigger or smaller and looked at different histograms representing this data. Okay, now let's talk about that relative frequency really quick. So what is the relative frequency then? So these were easy to answer because they were talking about frequency. But this one's asking about the relative frequency of trees between 20 and 40 feet tall. So what would we do here? Remember, relative frequency is the frequency of that category divided by the total. So first, let's figure out how many trees are between 20 and 40 feet tall. That would be this bar right here. So that's 4 trees. Can you tell me how many total trees we looked at? You can by adding up each one of these bars. We looked at 2, then 4, then 1, then 12, then 3 total trees. If you add all those up, that's 4 divided by 22. If you divide those, you'll get a decimal. Let's go ahead and round to the nearest hundredth. That's 0.18. And that's the same thing. You always take decimals times 100 to get the percent form. That's 18%. And we found the relative frequency. Relative frequencies can be reported as the decimal or percent form. So you can get to relative frequency from a frequency visualization. You just have to take into account what the total number is overall. And sometimes you have to do some calculations to find that. All right, so that's histograms. That's the one visualization we're going to use in order to represent those quantitative variables we've been really focusing on so far. The last thing we want to talk about here is kind of that type of variable we left hanging there for a bit. We want to talk about what do we do with the categorical or qualitative variables. Now, because they're categories, we can't do any calculations because there's no numbers to do calculations with. So what we are going to do is talk about a couple different ways to visualize qualitative data. And these are probably visualizations you've seen before. Histograms sometimes are a little less common to be seen, but bar charts, right? As you're looking down here at this example, it's probably something you've seen before. So bar charts used for that categorical or qualitative data. What's different? Now I do recognize that this looks similar to a histogram, but it's used for entirely different data and it's actually very different from a histogram. The one visualization piece you'll notice is that these bars have space between them. That's the huge visualization difference between a bar chart and a histogram. Now, also the horizontal axis and how it's labeled. The horizontal axis is not a number line because we're not talking about things that can be represented with numbers. The horizontal axis is labeled with those categories of the variable. So here are categories, our majors, and each bar is representing a different major, okay? So very different from a histogram, even though the visualization is a little bit similar. The vertical axis, however, is the same. We're still either going to see frequency or that relative frequency on the vertical axis. How many, in this case, students were in that category, or what percentage of students fit into that category. All right, so can you look at this bar chart and answer the questions? How many students have an education major? Pretty straightforward here. We just go to education and see that that bar height is at 3, and we're done. One good thing about bar charts too is we can see the difference between categories. So this one, next question asks, how many more students have an education major than an English major? Education and English, we can see the difference between those bar heights is just 1. So we can see that there is a difference of 1 between those two majors. Also, you can quickly see where the highest bar is to see where the most students are majoring. The highest bar is here at arts, so this answer would just be arts. Now, can you do one of those relative frequency questions with a bar chart? Can you tell me what percentage of students have an art major? And I have taken you through a few steps in these notes to find it, right? Because what 2 pieces of information do we need then? We first need to know how many students are in an art major. Looking at the chart, that's 4, because the arts bar is up at 4. And we need to know how many total students there are. That would be 3 plus 4 plus 3 plus 3 plus 2 plus 2. Your total number of students then should be 17 students. So to find that percentage, you will take 4 divided by 17. Again, I'm going to round to the nearest hundredth, so that would be 0.24 or 24%. Again, either version is okay. All right, so we've got the percent. We've used our chart to convert from frequency to relative frequency. Again, understanding how to use that chart to find a total. The last type of chart that we want to talk about, again, used for qualitative data, is a pie chart. And pie charts are very good for when we want to use relative frequency. Now, they can represent frequency. It's not that they can't. It's just especially good for relative frequency. So that's what you'll see in this pie chart down here. We're looking at someone's monthly budget, and the categories are broken up by percentages and how much they spend on rent, food, utilities, and other. Now, the only bad part about this monthly budget is that we have no idea how much they spend in either category. But if we have one piece of information, if we have about that percent, if we know the total or how much they spend in that category, we can find that missing piece. So I just want to review how to find those missing pieces. So if you know the total and you know the percent, so we want to know if our total budget is $4,200, so that would be essentially how much is in the whole circle. And we want to know how much money is just in this rent portion. I can use that percentage and this total to find it. What I need to do is just find 42% of $4,200. And to find a percentage of a number, you just take the number times the percent in decimal form to get how much is in that category. So if you calculate that, there is $1,764 in that category. All right, so percentage of a number just means you multiply. Now, the trickier one tends to be if you know the amount in the category, how much money then is the total. So this is an entirely different scenario, but we're going to use the same chart to find it. So in this scenario, this particular person spends $400 in this category of food, and we want to know what the total budget is. So we want to know actually what the total circle represents. Knowing that food is $400 and 25% of the budget. We can follow the same idea as up here. Now we took the total, but that's what we don't know. So we're just going to use the word total. We're going to say, okay, we're looking for that total. We would take it times the percentage, which we do know, that's 0.25, to get the amount in that category, which we know is 400. So if you're looking for the total, what you actually need to do is divide by that percentage to find it. To solve for total, we'll divide by that percentage, and when we do that, we'll see that the total budget is actually $1,600. Okay, so just a little bit of a review of percentages there as well, because we'll often be working with doing things like that anytime we're looking at a pie chart. All right, the last thing I want to just look at is what happens when you're creating one of these charts. So if you have a set of data, how do you create one of these charts? The first very important question is which type of chart you're going to create. You have to choose whether or not the data is represented by numbers or represented by categories. Once you figure that out, you're either going to do a histogram if it's represented by numbers, or if you have categories, then you can decide between a bar chart and a pie chart. Once that decision is made, the next two steps are very important. In all of the visualizations we looked at today, we had very clear labels, so we had no question about what was going on in the chart, about what the data was we were looking at. We had clearly labeled vertical and horizontal axes or legends if it was a pie chart. We had variable names included and units of measure included. Very important that you put all of those things in when creating one of these charts. Leave no question to the reader as to what's going on with the data. Another very important thing to do when leaving no question is to create a detailed title to your chart. If we were looking at the ages of students at Kirkwood in years, we need all that information in our title. If you put just ages, I have no idea what we're looking at. So be very detailed and be very careful that you fill in all the correct pieces of information. One really good way to do this is to do it using technology. So Excel is a great tool where you just plug in all the data and it would create one of these charts for you, and then you would just have to make sure that your title was correct and your axes were correct. Okay? Google is actually, I know that sounds silly, but Google is actually a great resource for saying, hey, how do I create a bar chart in Excel? And it'll give you step-by-step instructions on how to do that. You will be doing this. You will be creating a bar chart or a histogram by hand, or you can use Excel to do it in your first written homework. So if you are interested in it, I will demonstrate that in class when we have one of those sessions of face-to-face learning, okay? Or if you're joining via Zoom, perfect. So I will demonstrate this in class, but just know that Excel is a great tool. It is how I created every one of the charts in the notes here, and often how even charts in your textbooks are created, okay? So just know that's a great tool for you as well. All right, great job making it through the first section, and I'll see you for section 1.2.